Alright, so today we are going to solve this problem, maximum number of fish in a grid. This is a medium complexity level problem. So we are given a 2D matrix which consists of 0 values and some values greater than 0. The 0 cell represent the land cell, and the values greater than 0 represent the number of fishes, and those cells are water cells. So we have to return the maximum number of fishes a fisher can collect continuously in a grid. It means it cannot pass these 0 cells. So for this grid, maximum number of fishes a fisher can collect is 7. So we are going to solve this. We will use VS Code. So I have set up a helper function, the find max fish function, and the grid, sample grid, and I have called the function and see out its value. So we will directly write this function. We need an int fishes variable, which is initially equal to 0, and int max fishes variable, which is also initially equals to 0. Then we will do a grid traverse using for loops for int row less than grid dot size to check maximum number of rows, and inside this we will use for loop for columns as well, int c and c as well, c less than grid 0 dot size to track the value c is less than maximum columns. Now in this traverse we will check if the grid RC means its value, if its value is not equal to 0, it means it is the water cell and it consists of some fishes. So we will call our help function and pass grid to it. So inside this function we will also pass the row, the column, and fishes as well. So int r, int c, and int fishes, actually address of fishes. So in this helper function we will assign this value, as this is not equals to 0, so we will assign this value to fishes. So update the value of fishes plus equal grid rc. We will assign this value to this, and we will update its value to 0 as well, grid rc equal to 0, so that we will not again come to this cell. Now we will call this function, helper function, for its adjacent cells. So we will pass grid row column plus 1 and fishes as well, fishes, and likewise we will traverse to the column minus 1 and row plus 1 and row minus 1 in all 4 directions. So as this is a recursive function, so here we have a base case as well. So if we will check that if we are inside the rows and column ranges and the value of grid RC is not equal to 0. So if R is greater than or equal to 0 and R is less than grid dot size, and C is greater than or equal to 0, and C is R is less than grid size, and C is less than grid 0 dot size, and the last one, that grid RC is not equal to 0. Okay, if this condition, then we will assign this value to fishes. We will add this value to the fishes, we will update this value to 0, and we will traverse in all 4 directions. So once our one continuous recursion completes, so we will come here and we will check if fishes is greater than max fishes. Then do what? Assign or update the value of max fishes. Max fishes is equal to fishes, and one more thing, we will reinitialize the value of fishes to 0. Okay, I think we have done. Once we will outside this for loop, we will return max fishes. Okay, so now we will run this code. Let's see. I think we have done. So we need 7. All right. So now we will copy and paste these functions into the lead code. So here we get this. All right. Okay. All right. So boom. Wow. So the details are the runtime is 56 milliseconds, beats 96.4%. Wow, that's great. The memory 88.4 MB, which we beat it 85.9%. Wow, that's cool. So this is it for this time, and I will see you in the next one.